All right, so 10.5 covers evaluating different radicals with different indexes and how those graphs might look. So when you have an even root, that means the index, the little number right here, is an even number. Your domain is going to be from 0 to infinity. That's because you can't have square roots or quarter roots or so on of negative numbers. When it's odd, they're negative infinity to infinity because you can have a root of an odd number because an odd number of negative signs makes it negative. So evaluate if possible simply means plug in. So we would do -5 plus 1. -5 plus 1 is -4. There's no solution because you can't take the even root of a negative. Plug in the 3. 3 plus 1 is 4. Square root of 4 is 2. Now let's go over here to this cubed root. -7. So cubed root 1 minus -7. So subtracting a negative is like adding. So 1 plus 7 is 8. And the cubed root of 8 is 2. Finally, let's do 28. 1 minus 28 is -27. And the cubed root of -27 is -3 because it's an odd number. Here's 2 more. You go ahead and try those and see how you do. All right, if I plug in 5. 5 minus 7 is -2. That's an even, so there's no solution. 88. 88 minus 7 is 81. And according to that chart, the fourth root of 81 is 3. So we just put a 3 here. All right. Fifth root of -1. It's odd, so we can do it. And all the roots of 1 are 1. So it's still -1. And then the fifth root of 32. We go to our table. We have a fifth root, 32. So that is also 2. All right, now if we look at these two equations here, we call the first one a power function because we have different functions, based on the power. And then we call this one a root function because we have different roots based on the index. You can go back and forth between them using the exponent rules, but that's just what we call them when you see them. So here we have a power function. We could rewrite it as a fraction, and that would be 3/4. So if we wanted to turn it into a root function, it'd be the fourth root of x to the third. Then, if we were going to do that, we'd plug 16 in for x. So the fourth root of 16 to the third. Use our table. Fourth root of 16 is 2. And 2 to the third is 8. You also can plug this right into the calculator. This little caret button over here under the clear sign brings it up to an exponent. So if we type 16 caret 3/4, we'd get, well, it would help if I typed it right, 3/4, we'd get 8. If I typed 16 caret 0.75, we get 8. All kinds of different ways. We could also use the math button and number 5, or we put the 4 there and put 16 cubed inside. All different ways you can use the calculator. So same thing here. This is our power function. The root function would be the fourth root of x. If we plugged 81 in, this is even, so there's no solution. If we put that in the calculator, you would either get an I or you'd get an error depending on the settings of your calculator. My dog likes to have zoomies while I'm teaching. All right, the surface area of a person who is 66 inches tall and weighs W pounds can be estimated with this equation, where S is square inches. So the first A is find S if the person weighs 130 pounds. So we're just going to plug that in for the weight. Now, you could turn that into a fraction and do all that crazy math, or we can just type it in exactly as it is. 327, parentheses 130, caret 0.425, and we get about 2,588 0.1 inches squared. So that's the surface area of this person. Now, if the person gained 20 pounds, how much does the person's surface area increase? Well, if they started weighing 130, if they gained 20 pounds, they'd weigh 150. So let's start by plugging that in and get their new surface area. All right, so 327, 150, 425. We get about 2750.3. And we want to know by how much does it increase, so we need to subtract. So 2750.3 minus 2588.1, it increased by about 162.2 inches squared. So make sure you're answering the questions once you're plugging things in. All right, a graph is shown. So this is a graph of that equation. Suppose they weigh more than 50 pounds. So we're looking at some point anywhere over here. And then their weight doubles. Use the graph to determine if their surface area also doubles. So if they weigh 100 and then it doubles, they go to 200. That doubles their weight, but it goes from like 22,000 to 3,000. So I would say that didn't double. Let's look if we started at 200 and doubled to 400. Again, we went from about 3,000 to about 4,000. So I would say it doesn't double. It increases, but it doesn't necessarily double. All right, graph the following. So we're not doing these by hand. Why would you if you paid money for a graphing calculator or use the app? Y equals. So on your calculator, the top left button is Y equals. If you type those equations right in there, it'll graph them. So if we type X, which is the button right next to alpha, and then caret 1/3, and then if you hit zoom 6, the zoom will take you to a standard 10 by 10 window if you choose 6. So there's our cubed root function. If I did X caret 0.75, and then the last one, X caret 1.4, I can graph them all at the same time. Notice the colors. So the first one's blue, the second one's red, the third one's black. This calculator will graph them all. 1.4. So you can see all of that right on there. You don't have to graph things by hand. If you do it, take a picture and send me a picture of the calculator. Don't necessarily have to be things by hand. So this last thing we're going to do is the table shows the weights of various birds and the surface areas of their wings. So the top is our weights, the bottom is the area. We're going to make a scatter plot. I don't know if you remember how to do that, but if we hit the stat button, so it's stat, and then enter, we can put weight in X or L1 and area in L2. So I'm going to type 0.5, 2, 3.5, 5. And over here in L2, I'm going to type 0.069, 0.175, 0.254, 0.325. Now, to make a scatter plot, we need to make sure that our plots are on. So we're going to hit second Y equals and enter to get in there. And then we just want to make sure our plot is on. The type is the scatter plot. And then we're going to choose zoom 9 so that we can zoom into our stat. Zoom 9. And if you see, we have these dots here and then one way up there. Doesn't look very helpful, so I'm going to check and make sure I entered them right. And look, that last one was wrong, 325. Now let's try this again. Zoom 9. Very spread out. Let me see what happens if I delete these equations. It should zoom nicely. The app sometimes glitches a little bit versus the calculator won't glitch. Now we have our scatter plot. So again, you can just take a picture of that. They want us to find K. So we can choose any of the points. It doesn't matter which point. So let's say I picked this one. I'm going to plug the 0.175 in for A. I'm going to plug the 2 in for W. And then I'm just going to work to solve K. So 2, well, if I quit out, 2 caret 2/3 is 1.587. So we're saying 1.75 equals K times 1.587. Then to undo this multiplication, we would divide. So 0.175 divided by 1.587 gives us 0.11. So that's going to be our K. And it doesn't matter which of those points you do, it's going to be the same thing. So the new equation would be 0.11 times W to the 2/3. Now C says graph it in the same window. So we're going to hit Y equals, and we're going to type that equation in here. 0.11, choose our X, caret 2/3, and then hit graph. If you just hit the graph button in the top right, it doesn't change the window. And look, that line goes right through our points. So we know it's not exactly perfect on that top point, but it's pretty close. Then estimate the area of a 3-kilogram bird. So that just means use the new equation, but plug in 3. So 0.11 times 3 to the 2/3. So 0.11 times 3 caret 2/3. And we get about 0.23, what are we doing? Surface area, inches squared. So there we go. That is how you're going to see some radicals and powers in 10.5. Let me know if you have any questions.